Let's round out our conversation of three probabilistic sampling techniques by discussing stratified sampling. Stratified sampling is a technique in which we subdivide the entire population into individual subpopulations or categories. Each of these categories is known as a stratum. We then go ahead and perform simple random sampling within each of the strata. We combine the results of all of these into the combined final sample. For each stratum in our population, we need to decide the fraction of the total sample elements which are going to come from that stratum. This is called the sampling fraction, and this needs to be decided upfront on the basis of some logic. Inevitably, this gives rise to room for human bias. Coming back to our example where we were studying the users of a social network, a stratum here might consist of all males or of all college graduates, all users who meet certain demographic criteria. In order for our stratified sampling to meet the definition of probabilistic sampling, every element has to have a measurable non zero probability of being selected in the sample. And that in turn means that our strata need to be MESI, that is, they need to be mutually exclusive and collectively exhaustive. An alternative approach might be to select only from within a specific group or a specific subset of the strata. That would now technically not count anymore as probabilistic sampling because it would violate the definition that every element of the population have a measurable non-zero probability of inclusion in the sample. Even so, this form of stratified sampling is quite popular as well. One important note: within each stratum, the strategy that we use for further sampling is usually simple random sampling. This means that all population units within an individual stratum have the same probability of inclusion. Done right, stratified random sampling is a formidable sampling technique. Like other probabilistic methods, it greatly reduces the potential of human bias relative to non probability sampling methods. It also gives us a very highly representative sample, particularly if the sampling fraction that we choose from the different strata closely reflect their proportions in the total population. For these reasons, stratified sampling allows us to generalize quite robustly from the sample to the population. In fact, it's quite possible that we are even more robust than with simple random sampling because this way we are ensuring representation of niche groups which might have a disproportionate impact on the experiment depending on whether they are included or excluded. And in exactly the same manner, stratified random sampling is also